Question number 64. First, let's look at what we are given. So we have an object a certain distance above an unstretched spring. Then here you see that that spring is compressed by a certain distance d, and the object is resting on that spring. So here we could talk about potential gravitational energy. Here we can talk about potential elastic energy. If it moves somewhere in between, we can talk about kinetic energy. So that's just visually from the diagram. Let's read into what they're telling us. They give us the mass released from rest at a height of 65 centimeters above the light vertical spring. There we go. Hence, we can talk about UG initial. And kinetic energy initial is 0 because it's released from rest. The ball strikes the top of the spring and compresses at a distance of 9 centimeters. So remember, that needs to be 0.0900 meters. Neglecting any energy losses during the collision, the speed of the ball just as it touches the spring, and then the force constant of the spring. First, we went from initial gravitational energy to kinetic energy final, and that's how we're going to figure out the speed of the ball just as it touches the spring. mgh initial equals mv final squared over 2. Get rid of m. Even though they gave it to us, we don't have to use it if we don't need to. So then we have 19.6 times 0.65 rooted is going to be our V right before it strikes our spring. 357, well, technically 3.6. If I use 9.8, I can't go 3 sig figs. So that's my speed right before. Two ways we can figure out the spring constant. Let's go from this. If I say kinetic energy initial equals elastic energy final, then I'm going to say that my 1.8 is my mass. So 1.8 times 3.6 squared over 2 is going to be K. And then it says compressed by 9 centimeters. I'm going to do 81 10 to the negative 4th centimeters to meters over 2. 2's cancel. I got K to be 2880 newtons per meters. That is if I use kinetic energy of the ball right before it strikes. Then again, since they tell us neglecting any energy losses, I can say that originally my UG equals UG initial equals U elastic final. That's even easier. I would say 1.8, which is mass, times 9.8, which is G. And then it was 65 centimeters above, so 0.65 equals K. And then, again, it's 9 centimeters squared, so that's going to be 81 squared times 10 to the negative 4th over 2, from where K is going to be 19.6 times 1.8 times 0.65 over 81 squared, all that times 10 to the 4th. Let me round real quick. That will give me 2831, interestingly enough, newtons per meters. Do not despair over the discrepancy. Remember when we figured out our speed, the speed was 357. 3.569 squared, and run that real quick, newtons per meter, which is exactly what I got here. This was also 2.831 newtons per meters. So see, rounding does give us different answers, but to a certain precision, all right? So either way, that is how you would solve question number 64.